Hello and welcome. Really glad you're here. My name is Chris. This is Warrior. This is the next episode in a cutting edge, really exciting series with CUAS Hub as part of SAE Media. It's a UK-based think tank. They are specialists in drone technology. We here at Warrior follow innovation as much as possible. We're talking to military experts as well as the cutting edge industry innovators. And we have one right here, one of the top. You've probably heard of AV, used to be called Aero Environment. They are a really impressive firm that does a lot of unmanned systems. They have just pioneered a really cutting edge laser system for an infantry squad vehicle. So let's hear from the expert. We're joined now by Mr. Garrity. He is the VP of Directed Energy for AV. Welcome. Thanks for being here. It's great that you took some time.
No, thank you so much, Chris. It's great to highlight some of the incredible capabilities that us and some of our service partners are getting out into the field. The UAS fight isn't going anywhere, and we need faster solutions that get after that proliferated threat. So really excited to talk to you today, Chris. Thanks for the opportunity.
Oh, excellent. Well, you guys are sort of veritable rock stars, right? Well, tell me about this AWP-HEL. High energy laser has been around in various variants, you could say, in terms of one put on a helmet. Tell me about this one that's on an infantry squad vehicle. I mean, this has been hoped for many years, the idea of expeditionary power being small enough form factor to propel something like on the move counter drone tech.
100%, Chris. Yeah, if you look at the history of directed energy, it dates back decades. A lot of science and tech experimentation, but we're finally at the forefront of fielding DE weapon systems for the counter UAS fight. And so a lot of those lessons learned from some of those large programs, like you mentioned, that went on HEMTT, like HELMD and others, have spiraled into making these systems like AMPEL or Army Multi-Purpose High Energy Laser a massive success. And so that's integrated onto the ISV as well as onto the JLTV and fixed site instantiation. So those lessons learned for acquisition, tracking, pointing, for reliability of these systems, all at the forefront of us and our industry coalition's minds in making these systems successful.
Gosh, I'm flooded with questions. I love your expertise. Could talk to you forever, but let's talk first about the technology of this. I mean, one of the big challenges, which is why the AFRL has been working on this for fighter jets, how do you get mobile expeditionary power sufficiently packaged to generate a laser weapon system on something smaller? I know they started first with the C-130. The Army has had success putting it on a Striker. How did you get it on an ISV?
Yeah, so it all really dates back to our original Locust that we started in 2019, which was a palletized fixed site system that fit on a 463L pallet. And then we took that system, we deployed that overseas, learned a lot over a couple of years, and then took that into a repackaging exercise to fit it onto that ISV. So the same power that's packed inside of other successful systems we've deployed with the Army and other services, going into a design with some of our partners at GMD and at the Army to lightweight that without losing too much of that trade space. So it was a really exciting prototype for us, and I think it's helped fuel other lessons learned, like how we've better integrated onto the Striker with our partners at DRS for our DE Striker system that you've probably seen in the news as well. So.
Oh, wow. Okay, sure. You guys are all over this. Well, I wouldn't be surprised if the Air Force jumps on this for fighter jets, if it's really having success kind of miniaturizing the technology. But let me ask you this. Tell me about the testing you've done. And I'm interested in the counter swarm elements in particular, because that's been such a challenge. And then, of course, with lasers, you go at the speed of light, you're scalable, you're low cost. Tell me a little bit about the testing and kind of what the merits have been.
Yeah, and that's what's most exciting about where we're at with directed energy today is the testing, but also the real world deployments and lessons learned we're getting are pushing these systems to adapt quickly to how the battlefield is actually being fought, in concert with actually making sure that we're getting after not only the fight of today with individual UAS that we may see, but looking at what we see in the European theater right now with those swarming situations. Making sure that these systems are right-sized for that and affordable. So we've had a lot of success in testing at Yuma, White Sands, out at the Redstone Arsenal for pre-shipment acceptance testing, and really working with our government partners and making sure that these go through rigorous safety qualifications prior to getting in the hands of soldiers.
Roger that. Has this been tested against swarms or representative swarms? There may be even some digital engineering or some simulations.
Yeah, we go through, and I think we recently did a count. Thousands of individual drones have been killed by these systems in tests. Some of those are in quasi-swarm scenarios. Some of them are individual. Some of them are at longer distances than even what we're expecting to see these systems engage at. And so we're putting these systems through the paces for all scenarios of drone warfare.
10-4. It reminds me of Admiral Clunder from the Navy's ONR years ago, talking about laws. Laser weapon systems, one of the first ones to ever deploy on a ship on the USS Ponce. Can't
Mhm.
believe all this is kind of coming back to me. But that was on a ship where the
100%.
mobile power challenges were a lot different.
Yeah.
What kind of form factor is this being packaged with to support an ISV? Because that's a very expeditionary vehicle.
Yeah, Chris, I'm actually super glad you brought up the Ponce because we actually will hopefully be announcing sometime here soon a roll-on, roll-off capability for that maritime fight to kind of answer what's being seen in the Red Sea. So I know we're working through some PAO processes on this end, but really exciting to get that out for a roll-on, roll-off capability. But to your question about how we're getting after the repackaging and how we're scaling that power, really it has a lot to do with maturing basic technologies, right? So on board for most of our systems, you have onboard power and thermal management systems, intertwined into our actual high energy laser source. So these fiber amplifiers. Fortunately for us, both through those lessons learned that I've talked a lot about, and I could go all day on all of our lessons learned, but that scaling factor has made these systems more efficient and reliable. And so it's a whole lot easier for us to repackage those to meet different platform needs and requirements. Just based on the fact that we know a little bit more of how to make these systems reliable, the technology has gotten a lot better, and ultimately we're really focusing on getting these to be soldier maintainable and a little bit more modular, so you can have increased rates of repairs in field and also minimize that cost tail that you see with traditional weapon systems as they go into CLS.
I'm tracking. Want to ask a follow up on the maritime, but first, when I think lasers, I think kind of pencil beam. I think precision, and I know they can be used for optical assessments as well in
Yeah.
terms of an ISR component, right?
Mhm.
But how would you have something you would need a high volume, a mass of pencil beams to take out a swarm? How are you doing that targeting, and how are you kind of simultaneously operating a number of small beams?
Yeah, so here at AV, we actually have a software product that is interconnected between all of our other different products that we're delivering called AV Pinpoint, and they're part of our AV Halo software architecture. And that allows us to really get after the incredibly challenging task of acquiring targets, tracking them in clutter, and engaging them really quickly. So when you're looking at, and I like to use the comparison of you're effectively taking a beam of light, shooting it kilometers away, about the size of a diameter of a quarter, and precisely tracking and following drones as they're moving. When we've been able to perfect that, and that's really our differentiator in the market, is that tracking, pointing, and acquisition technology, we're able to engage threats a whole lot more quickly and effectively. So from a swarming perspective, you're able to engage one drone and quickly move on to the next without having to have multiple systems, right? So that's how we've kind of addressed that fight and scenario a little bit different than what I think we're seeing in warfare today.
Oh, that's interesting. Well, how would you counter, say, hundreds of mini drones? Can you move fast enough? I mean, lasers are the speed of light. So, in theory, if you can target all of them,
Mhm.
maybe
Yeah.
you can get to all of them.
Yeah, and working with how those systems are deployed, whether it be for protecting a forward operating base or other critical assets, looking at how those ConOps are set up so you're maximizing the lethality of the laser weapon system and really focusing on not only, counter ISR drone missions today, but scaling into where those swarms may be in the future, kind of like what we again see in Europe today.
Roger that. Well, I want to follow up on the mobile element of this convoy protection and the expeditionary element because that's a big focus for the Army. But before I forget, I had the great honor of talking to the commander of Carrier Strike Group 2, who's over in the Red Sea. I
Yeah.
love what you said about the maritime applications. We
Mhm.
talked about proximity fuses. We talked about how fighter jets could take out drones.
Mhm.
It's interesting to learn about this because when it comes to defending swarms, defending a ship from swarms, you think of Sea Whiz, you think of closer in kinds of interceptors. How would this apply to a ship? I mean, it seems like there'd be a real need there.
100%. And I think, part of our mantra is taking our counter UAS fight any platform, anywhere. And so when we look at the maritime challenges that we're seeing with defending ships or fleets against drone warfare, having that same piece of kit that's proven to go onto the ISV and onto fixed site platforms, having that be something that can roll on, roll off of other carriers or other kind of maritime assets is really important. And so proven technology, getting after that fight really quickly. And again, it goes to, a lot of those kinetic effectors do a great job, but the cost per shot is very expensive, right? By comparison, laser weapons are perfectly suited for having that proliferated threat base being negated by a much lower cost effector.
Roger that. Well, let's talk about the expeditionary element of the Army. And then I want to talk about networking integration, but I want to be sparing with your time. But when it comes to something that's multi domain or expeditionary, like the ISV, that can be sling loaded, that could roll off a large Air Force cargo plane in some cases, how are you packaging this so that you can sustain the power over time or through austere conditions, or perhaps in a convoy type scenario, or as you mentioned, a forward location like a fob?
Yeah. Yeah. So I think, again, we always try to be where the fight of the future is. And so by having these assets integrated well onto maneuverable platforms, it gives the Army a Swiss Army knife of counter UAS capability, right? So you're able to have onboard radar that's able to help augment and detect. You have onboard C2 feeds, and really making sure that the soldiers that are operating this kit can go anywhere with it that's necessary and get after that mission. So, oftentimes we look at how FOBs are structured. So you have on-premises power generation, whether that be through shore power or generators to help charge up before you go after on missions. But really, I mean, it is a Swiss Army knife of counter UAS capability.
10-4, one of the things you hear a lot about is the importance of layered defense and a variety of countermeasures and effectors. So, how does this integrate with, say, a more holistic counter drone system that might even be feasible on the move, where perhaps you have a kinetic interceptor, maybe you need EW? How does this integrate with that or kind of interface? And is it part of those other countermeasure types of applications?
Oh, absolutely, Chris. I'm so glad you brought that up because I think, again, that layered defense is so critical because it's not a one size fits all for all scenarios. Lasers really cover, I think, the broad end of that spectrum to get after whether it be swarming scenarios or expanding your ability to fight further than you could with a traditional kinetic effector, right? You're going kilometers out to help engage these threats before they become a bigger problem for what you're defending. But also, I mean, a majority of this time, because these systems have such great ISR capabilities, you're able to track and target whether it be drones or other objects of interest, and help really kind of fill that into some of the other voids that might be in that layer defense architecture. So really that ISR capability and the ability to track using the AV pinpoint that we discussed, helps just further push the boundary of making that layer defense more effective and more lethal.
That's excellent. That's excellent. Well, this is my last question then. We love to kind of talk AI because that's such a huge focus. To what
Right.
extent is sensor to shooter pairing? Because there's a real push and successful applications of using AI systems to essentially aggregate and then deconflict or pool and then perform analytics on incoming sensor data from otherwise disparate pools or sources of information. To what extent can this integrate into kind of a holistic kind of counter drone system that's enabled by AI to take those decisions from minutes to milliseconds?
All right. No, I think that is one of the key emphasis areas that we're focusing on. You'll hear a lot in whether it be Army, Navy, Air Force, acquisition discussions, MOSA, right? Modular Open Systems Architecture. And so a key area that we've been focusing on is creating those and fitting inside of the traditional DoD construct for MOSA reference architectures to be able to integrate, whether it be today or weeks from now or years from now, some of that cutting edge technology. AI ML is a big portion of that. We do that a little bit inside of AV today, and we're continually looking for best of breed integrations to make the operator and the warfighter's job easier and make them more effective in getting after defeating these threats.
Mr. John Garrity with AV, thank you so much. Are you a PhD in physics or something? I appreciate your expertise. This is great.
No, Chris, I really appreciate the time today. We're excited to talk about this cutting edge technology that I think in the next couple of years is going to be on every battlefield, and we look forward to providing that. So thank you, Chris.
Absolutely. The counter drone swarm. I mean, the DoD has set up a task force, and and innovators like yourself are really trying to stay in front of this. The threat equation is very, very serious. I want to thank you for supporting and being with our series. And it was an absolute pleasure to talk to you.
Terrific. Look forward to talking again soon, Chris. Thanks.
You too.